Hello, this is Ms. DB, and in this video I'm going to help you out with some of the problems on the 9.2 worksheet. The first part is on circles and the second part is on finding the area of a regular polygon, and that's the part we're going to focus on today. So the center of a regular polygon, shown here as C, is equidistant from each of the vertices. So from C to F is the same as C to E, same as from C to D. So they mark those all with those little equal marks. So you can divide this into congruent triangles. This pentagon is divided into 1, 2, 3, 4, 5 triangles, and they're all the same. So if I could find the area of one of them, then I would be able to just multiply that by 5, and then I could find the area of the regular polygon. That's essentially what we're going to do in this lesson. So when we do that, we are going to have to know the angle of this right here, and of that triangle, and that is known as the central angle. And actually, if we divide that triangle, this one right here, this FCE, if we divide that in half by drawing the altitude of it, then we have a right triangle. So this right triangle is BCE, and then we can use trigonometry to find the different sides and things that we need for that. And this little right triangle, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So if I could find the area of just that one right triangle, I could multiply by 10. That would work too. There is a formula that is somewhat useful to find the area of a regular polygon. If you know the apothem, that's that line from the center of one side up to the center of your polygon, but you're not given that very often. If you are given the apothem, or if you can find it using like trigonometry with the right triangle, then you can use the formula that the area is equal to 1/2 times the apothem times the perimeter, and you're not always given the perimeter or able to find it easily either. So this formula is only as good as being able to find A and P. Those are not generally things that you would know both of. So we will usually have to go back to what are we really doing? We're really breaking this into triangles and then finding at least this part of the triangle, which is the apothem, and then probably this part so that we can find the perimeter of the triangle. All right, so I'm going to go through how to begin the problems on your worksheet, and since you'll be given different information for them, you will be doing each of them just a little bit different. All right, so in number 8, we have a hexagon. It's a regular hexagon. All of these will be. We are given that one side length is 6. So we could find the perimeter of this because there's 6 sides and they're each 6, so that's 36. But we don't know the apothem, the A part of this formula. So in order to find that, look at this little right triangle right here. This little right triangle has one side of 3, so we've got that, but we don't know any other information. However, we can find this angle up here because there's 360 degrees all the way around in every polygon from the central, all the central angles added together, and there are 1, 2, 3, 4, 5, 6 of them. So each of these triangles is a 60-degree triangle. And we broke our 60-degree triangle into pieces, so now this is a 30-degree for that angle up there. And that's enough now to find the side that we want. We want to know what is, I'll call it even A. We want to know what is side A. So you think about your trigonometry that you know. And I don't know the hypotenuse, and I don't really need to know that. But I know that the tangent of 30 degrees will be equal to the opposite side of 3 over the adjacent side of A. And we spent a whole chapter working with trigonometry, so you know that you need to multiply both sides by A to get it out of the denominator. And that will be equal to 3. And now to solve for A, we need to divide by the tangent of 30. Now, some of you may have memorized the tangent of 30. You're thinking ahead, and that's just fine. But if you didn't, you can use your calculator, and you can go 3 divided by, I'm going to use parentheses here, the tangent of 30. Now, your handheld calculator, you'll push tangent and then 30. This computer calculator that I'm showing you is somewhat backwards, and I have to do 30 tan. But you can see up here that it's doing the tangent of 30. And then I'll close my parentheses and hit equal. So I'm taking 3 divided by whatever the tangent of 30 is. and I get 5.196. 5.196. Did I get all the digits that I need? 5.1961. Yep, I'm going to round to 3 decimal places because I do not want to multiply my rounding errors when I use it in the formula. Now I'm ready to use the formula because I know that you could now find the area of this little triangle and you could multiply by 10. Let's do that. The area of a triangle is equal to 1/2 base times height. So I could take 1/2 of 3 times the height of 5.196, and when I'm done, I'll find the area of one of these little right triangles, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I said 10, but there's actually 12. So whatever I get by this, I could multiply by 12. Or I could use this formula, which says that the area will be equal to 1/2 of the apothem times the perimeter, and the perimeter I found was 36. Now both of these answers will get me the exact same thing because 3 times 12 is 36. So right there you'll get the same answer. If you want to do some math in your head, I could take 1/2 of 36 is 18. Now on my calculator, I still have this 5.196. Well, I have the whole thing. So I could go ahead and multiply that by 1/2 times 36 or by 18. And this is really a very exact answer, 93.53. 93.53. Now I said I was going to start this one, and I ended up doing the whole thing, but that's okay. I won't on the other ones. And area is always squared. If I had rounded this to like 5, then you would get 5 times 18, and you would see that you would be losing a good chunk of your area there. So it would be quite a bit off. All right, let's look at how you would do some of these other problems if you're not given all the same information. In this one, it's a heptagon that's 7-sided with every side length of 2. So each of these sides is 2. So you could easily find the perimeter is 2 times 7. The formula for area of a regular polygon is 1/2 A times P, with A being the apothem, and that's usually the part that's a little bit more tricky. So I'm going to go ahead and draw in my triangle. There'd be 7 of these, and of that triangle, that's 2 here, and now I'm going to split that in half and create the right triangle that would only have a side length of 1 here, because then I can use trig. Now I don't know any other sides, but I can find this angle. I can take 360 divided by 7 to get that angle, and then I can divide that by 2 to get this angle. So let's do that on our calculator. 360, you're going to get a decimal, divided by 7 is 51.42. And then I'm going to divide that by 2. So that angle that I'm looking for is 25.71 degrees. Now I can use trigonometry to find my apothem. Remember how we did this before? We used the tangent. We said that the tangent of 25.71 will be equal to the opposite side over the apothem. And I can finish this to find the apothem. I can multiply both sides by A, divide by the tangent of 25.71. This is 1 here. And then you'll find your apothem, and then you can put your parts back into your equation. So it's going to be very similar to number 8. Now, number 10 is a little different because we are given this side of our triangle rather than the side of the pentagon. So let's see what we got. There will be 5 of these triangles with 6 here. Let's divide that into its right triangle. And the 6 would be here as well because each one of these is the same. And I don't know this side. I need to know the apothem. We can find the angle the same as we did before. There's going to be 5 of these triangles, so 360 divided by 5 will give me this angle, and then divide that by 2 to get this angle. And once you have that, you're not going to use tangent for this one, because in this one, we're going to find this angle. Let's see what it is. 360 divided by 5 is 72. Divide that by 2 to get 36. So we don't want to take the tangent of 36 because we don't know this side. The tangent of 36 would be an unknown over an unknown. But if you take the cosine of 36, that will be equal to the adjacent side over the hypotenuse. And you'll be able to find the apothem from that. Now, this time we don't multiply both sides by a, we multiply by 6. So we only have one step to find this. The apothem will be equal to whatever 6 times cosine of 36 is. But we have another problem in that we do not know the perimeter, and we don't know this side. So we do need to find, let's call this side B. We need to find side B as well. So we can use the same right triangle to find side B, and then we can multiply it by 2 to get the one edge of our pentagon, one side of our pentagon. So I'm calling this B. So I don't want to use cosine because that was to find A. Let's use sine. The sine of 36 is equal to the opposite side, which is B, over the hypotenuse, which is 6. So that says B over 6. And then I can multiply both sides by 6. And whatever you get for B, remember that's only this right triangle's base. Multiply that by 2 to get this whole side, and then there are 1, 2, 3, 4, 5 of them to get the perimeter. So that's how you'll do 10, and then you'll plug it back into the formula. You'll have the apothem, you'll have the perimeter, and you can finish it up. Okay, one more to look at. This one has a side length of 5. Let's draw our triangle in there. So there would be 8 of these triangles. So we have one triangle with a side of 5, and then if we split that in half, we would get a right triangle with a side of 2.5. Half of 5 is 2.5. We need to find this angle and then divide it by 2 to get this angle. So 360 divided by 8 will get me this angle, divided by 2 to get this angle. And then we will use tangent to find the apothem, and then the perimeter is going to be easy enough to find in this one because you're given that the side length is 5, and you just have to multiply it by how many sides an octagon has. All right, so I hope that helps you out. Good luck. Please let me know if you get stuck on any of these, and have a wonderful day.